Hello friends, welcome back. Today we are going to look at the design of septic tank. Couple of questions we are going to first ask, that is, what is a septic tank, what it does, how it looks like, and how to design it. So before starting and going ahead, I would like to request every one of you to please kindly like, share and comment on my video. Please kindly comment with your suggestions. Your like, share and subscribe will encourage me to make more and more such design videos. Thank you. Let's move ahead. So what is a septic tank? Septic tank is nothing but an anaerobic treatment plant that is used to treat waste from households, scattered homes and standalone establishments. You might have seen this septic tanks on the bottom side of your building. If not, please kindly go and check. So what it does? So it is a closed tank which settles solids. It helps in flotation of grease and oil. The grease and oil is generally the waste of every household. And finally, since it is anaerobic, the tank is closed. It helps in decomposition and digestion of organic wastes and sludge anaerobically. Anaerobically means that is without oxygen. So there is no oxygen, hence it is an anaerobic treatment tank. Now I'm pretty sure you must have encountered a septic tank. So this is how it looks like. It is generally underground. It is bored underground, and you can see the vents given on top. Then there are inlets and outlets. And how to design this basically? What are the considerations? What are the design considerations? What are the norms that we are going to look at first? And then we will see a example problem which will help us to understand the design. Now, what are the parameters? The shape. Generally, a septic tank is rectangular in shape. Minimum length is 1.5 meters and minimum breadth, that is B here, is 0.75 meter. The ratio of the septic tank, that is length is to breadth, is generally 2 is to 1, 3 is to 1 and 4 is to 1. These are the normal trends which generally people use and hence they are standardized. Depth is around 1.2 to 2.5 meters. Detention period. Detention period is nothing but how much time a water droplet, when it enters the tank, how much time it spends inside the tank before it moves out. So generally it ranges from 8 hours to 48 hours. It is dependent on the temperature outside. So if it's a bit of a cold weather, the reaction will take time inside. That's why the more time has to be given. And if there is a hot weather outside, so the reaction may occur fast. And but usually 24 hours is what is taken. Then sludge contribution. So 75 liter per capita per year is the standard which we take. So 75 liter is the sewage or sludge which is contributed by every person every year. Freeboard, which is a free space given in between the concrete and the level of the tank, that we will be seeing in our subsequent slides. Then bottom slope, there is a slope given so that the sludge settles, that is 5 to 10%, and ventilation stack. So some some hose or some pipe outlet is generally given for the gases to go out. Otherwise, there will be a buildup of methane, which is dangerous. 50, that is more than 50 in diameter. Now let's see how we design a septic tank. For that, we'll be taking a very simple example. Now let's say we want to design a septic tank of a colony which is having around 40 households. Now assume that every household is having 5 persons, 5 persons per household. So this makes it 40 into 5, that is 200 people. So we are designing a septic tank for 200 people. Now next is how much water or how much sewage is generated per head. So let's assume, for the sake of easy, let's assume 100 liter per capita per day. By CPHE or standard, it is around 135. liter per cap per day. But as I said, for the sake of making the problem easier, we are assuming 100 here. So let's see. So now total quantity of sewage which will be produced every day will be nothing but total number of people, that is 200 into 100, that is 100 liter per capita per day. So it will come out to be 20,000 liters per day, or simple words I will say 20 meter cube. Now retention time we are taking as 24 hours here. Then as I said that 75 liter of sludge is generated per person per year. 75 liter per person per year. Now also let me tell you one more thing, that the sludge needs to be cleaned after every 5 years. So there will be buildup of sludge inside that tank. So it needs to be cleaned. 75 liter of sludge is generated per person per year. And for 5 years we need to design, because we need to clean it once for in a 5 year. That's why our tank should be able to hold that much capacity. So total sludge which will be generated will be 75 into total number of persons, that is 200, and number of years, that is 5 here I am considering, which will be 75,000 liters, or you can say 75 meter cube. So total volume which we need to design is nothing but 75 meter cube for sludge holding, and 20 meter cube for the sewage flow, that is a liquid inflow. So it is nothing but 95 meter cube. That is the design. Now the depth, what I am assuming here is say 2 meters. So this is the volume. So you can understand that the volume is nothing but length into breadth into depth. So here I am considering this as a h, which is d. So if I divide volume by depth, I will get the surface area. That's what I am doing here. So 95 meter cube is my uh, volume. So I am dividing it by depth, which is 2 we have assumed. It will give me the area of the free surface, which is 47.5 meter square. So this is the area which we are getting, and depth we have got. Now length and breadth we don't know. So as I said that length is to breadth ratio is taken as 2 is to 1, 3 is to 1, or 4 is to 1. So as a standard I will take it as a 3 is to 1. This means my length is nothing but 3 into b. So therefore my area, which is length into breadth, which is equal to, I calculated here, 47.5 meters square. Length is 3b. So I am replacing L by 3b is equal to 47.5. Now if I solve this, I get b is equal to 4 meter, and hence from this equation, that is length is to breadth ratio is 3 is to 1. So if my breadth is 4 meter, I get length is equal to 12 meter. So I have got my breadth, length, and my depth is 2 meter. And as a part of norm, so freeboard has to be given as 0.5 meter. So these are my design parameters. I have got the length, breadth, depth, and also the freeboard, the free space which I have to keep. So now let me go to the actual design of this treatment plant, the septic plant for 400 for 200 people. which we have designed and how it will look like. So that is how it will look like roughly. You can see this is the ground level, and below the ground level the tank is constructed. This is the depth, and you can see this is the width which we calculated. The width we calculated is 4 meter, and the length which we found was 12 meter. As I said, on a standard basis of freeboard is given, so this is nothing but the freeboard. It is a that is a free space between the concrete construction and actual surface water level. So this is the sludge which gets collected, and the house, the ventilation or inlet you can say which is given is here, and the outlet is given on the other side. Roughly that is how it looks like, and how this is how it is managed, or this is how it is designed. So if you liked the video, please kindly subscribe the channel. I am getting very less subscribes after even posting such interesting videos. So I request you for that. Thank you very much. Let's meet again.